Thank SuSanA, the SuSanA organizers, and SEI for giving us the opportunity here to present our work in South Africa and Switzerland. And it's about recovering nutrients from urine, and by recovering nutrients, how we can promote sanitation. Please, the next slide. Our main focus is Durban, and especially the peri-urban area of Durban. And there, to promote sanitation, urine diverting dry toilets have been built, about 75,000. And you see them all over the landscape. You see those red circles. And the basic goal is actually to provide sanitation in an area where it's hard to build a water-borne sewage system. Next slide, please. Most of you will be familiar with urine diverting dehydration toilets. The main purpose of these toilets is actually to keep the feces dry and to enable the drying process of feces. By that you can remove a lot of the water, 80%. That means that the volume will be much smaller, but you will also kill a lot of the pathogens. So it's much safer to handle these feces later. The urine quite often is collected, but also quite often it's actually just discharged to the ground, which can actually cause some environmental problems. And so this is not a good idea because of the environment, but also because urine actually contains a lot of nutrients, which we will see in the next slide. This slide is based on some research that we have done in Nepal. In the earlier project, we have done this project together with ENFO, an organization in Kathmandu, and with UN Habitat. And we wanted to recover nutrients from urine, especially phosphorus, by struvite precipitation. And we also looked at the financial fertilizer value in urine by comparing the urine concentrations which fertilizers which are actually sold in Kathmandu. What we see on this slide is that phosphorus alone, the main ingredient of struvite, is actually only 15% of the urine value, fertilizer value. So if we want to get most out of the urine as finances, as fertilizer, we actually have to recover all of the nutrients. And this was one of the goals of the Vuna project. Next slide, please. So the Vuna project not only looks at the reactor technology, although it is a big part of the project. We also look at the management of dispersed urine tanks and reactors. So how can we actually collect the urine, and how can we make sure that the urine collection is optimized and also the operation of small reactors in the landscape is actually optimized. And as a third objective, we also look at socio-economic boundaries, such as the acceptance and also the overall economics of this system. So we are in the final year now. The whole project started in 2010. Next slide, please. Here we see all the different activities. So the project actually also grew. On the left side, first we see the urine collection networks. So we established actually a urine collection system in the field together with Ekane Water and Sanitation. And we actually tested how urine collection could be done in the field. In the second activity in this set of activities, we did some computer modeling, performance models, to find out how we could actually optimize the urine collection. So to collect most of the urine at the least costs. And this is also done now in a larger business model, optimized collection, which not only looks at the urine collection itself, but also at some other economic factors. Below that, we see the urine treatment processes that we look at. One of the processes, the first one on the left, is actually nitrification. Purpose of this process is to stabilize urine. After collection, most of the urea, basically all of the urea, is degraded. pH increases, and this, one of the consequences is the bad smell that we all know, but this also means that a lot of the ammonia actually volatilizes. To prevent that, we can use nitrification. After nitrification, we have a stable solution. And this stable solution we can later concentrate in a distillation reactor. So we remove most of the water, and then we have a highly concentrated nutrient solution or fertilizer. Those two processes combined are the complete nutrient recovery process, which we implemented here at EAWAG in Switzerland, but which we also implement in Durban. Besides these processes, we also looked at electrolysis as an option for urine treatment. The advantage of electrolysis is that you could have really small reactors, so maybe even a reactor which is installed directly beneath the toilet. And another process we actually optimize, because we already did some research on it before, is the struvite production. With struvite production, we really focus on phosphorus alone, so we don't really recover most of the other nutrients. Then we have the socioeconomic aspects. One of those activities is actually how we can use incentives, like financial incentives, to encourage the people to bring urine to a collection point. We also focus on hygiene education to get the people more familiar with this new kind of sanitation system. And we also look at the social acceptance with questionnaires and interviews. Then we have this section of risks of using urine. On one side, this is pathogens. We look how pathogens are degraded in urine during this urine treatment processes, but we also look how pharmaceuticals could be removed. And in the end, we're working together with universities in Switzerland, but also in South Africa, to test the agricultural value of urine. For all those activities, we actually produce some brochures that you can download on our website. Next slide, please. This slide shows the urine treatment reactor, which is installed here at EAWAG. On the left side, these two columns are the nitrification reactors. When we took this picture, only one column was operated, because we have two tanks, so only the urine from one tank was actually used. And on the right side, we see the distillation reactor. And we also see the values of energy which are given on the slide. And the nitrification reactor requires about 45 watt-hours electric per liter, and the distillation about 80 watt-hours per liter. So altogether, it's 125 watt-hours per liter. And this low energy demand for the distillation is actually due that this reactor recovers nearly 90% of the energy. Next slide, please. This is just a short snapshot on the urine collection activities. So we have two basic approaches. One is the institutionalized approach. So Ekane Water and Sanitation, their field workers and co-workers are going to the toilets themselves, and they get the 20-liter urine tanks, bring them to a pickup, and transport it to the urine treatment facility. While the incentive approach, there we also want to motivate the people to bring the urine to a central collection point, which is shown here by this green tank, and they will get some money. And Liz Tilly actually did her PhD, or is doing her PhD, on finding out how people actually react to different kinds of incentives. So the reactor I've shown before and this urine collection, those are only a few aspects on the whole system. This talk is actually too short to look at all the different aspects. Next slide, please. This picture here was taken at the last annual meeting here in Zurich. The next annual meeting, or final meeting, will actually be in Durban in August this year, and we hope that we can actually present a lot of aspects of our project. And just to remind you, what is the goal of the overall project? It is to produce a fertilizer from urine, and possibly a valuable local fertilizer which can be used directly there in agriculture. By recovering the value which is in urine with fertilizers, we want to lower the cost for sanitation, and last but not least, we also want to reduce the pollution of water resources, the groundwater. Next slide, please.
Thank you, Kai. I think this should be the last slide.
Yeah, so we have the funding and project partners here. The whole project is financed by the Bill and Melinda Gates Foundation, and it's a collaboration of EAWAG, Ekane Water and Sanitation, the University of KwaZulu-Natal, and the two federal technical universities at EAWAG. And just now it's the last slide, if you please show that. Nelson? Yeah, here you see actually the homepage, vuna.ch, where you can get some more information.
Thank you very much. By the way, what is Vuna?
Vuna is a word in isiZulu, and Vuna means harvest. So we want to harvest the nutrients from urine.
Okay, that's perfect. So yeah, just some few questions to you. I mean, you mentioned the incentive approach that colleagues are searching on. Could you say something about the kind of incentives that communities are responding to? If you have some figures, how much communities are ready to receive?
Yeah, so the incentives in the beginning, there was a plan to use different kinds of incentives. Those could be vouchers in a nearby shop or something else. In the end, it was actually rand, money, South African rand. And Liz looked at different amounts of money per liter of urine. And at the moment, she's evaluating the results, and they should be available in the end of the project.
Okay. On the technical part, you talked about using urine as fertilizer. I know you may have loss of ammonia, the volatile ammonia. How do you handle that?
Actually, that's the thing that's the reason why we actually use the nitrification process. Because with this nitrification process, we can stabilize the ammonia. We have hardly any loss. I mean, the main loss might occur during the urine collection from the toilet to the reactor. So we have to make sure when we collect the urine that the tanks are really closed. But during the process itself, we might lose about 3% of the ammonia.
Yeah, so just to conclude, you've done this in Nepal and now in South Africa. What you say you find as any lessons from cases that you have?
Yeah, I mean, from Nepal, one of our first lessons was that just recovering phosphorus as struvite is not enough. So we should recover more. We should also especially recover all the nitrogen compounds. That's the reason why we actually switched to this nitrification distillation process. Another lesson was that transport is really costly. And this is the reason why we really focus on those two aspects. It's the treatment of urine to recover all of the nutrients and also urine collection, that we also use a business model and computer simulations to optimize the urine collection. And I think something else what we realized is that it's actually really important to make sure that the pathogens are removed and also that the pharmaceutical content is low in the fertilizer product.
Thank you very much, Kai. Very interesting project, and wish you good luck.
Thanks a lot.